Hi, this is a neat problem that I saw on Twitter that comes from OpenMiddle.org. It's a cool little problem. You get an expression. You can see it down here. And the idea is you're setting x to a different whole number between 0 and 9 to make each value as large as possible. And this is a way to learn about order of operations, to learn about how different operations have different actions on the value of an expression. I think it's a nice exploratory situation, and I think it plays really nicely with some of the features that we've got in Graspable Math, so I thought I would just think it through, and then I thought I would tell you about it. So the main thing here is that I've built an example here in the center that you can play around with. And here you don't have to keep the constraints, you don't have to keep each number separate. You can see, I'll just move this right down here to make it a little bit less visually confusing with the scrub mode, but you can see the total expression value is 34, and it comes from all of these. And you can see there's sort of a branching here, where this 2 comes straight down and is just a subtraction off the top of it. But some of these other terms are a little bit more complicated. This 2 is getting multiplied into whatever the rest is, right? It gets multiplied in at this moment. This 2 is coming from over here and getting multiplied in. And then you've got this third expression, that's the exponent. And then once you sort of figured that out, you can actually see how each of these different terms affects the end result. And you can see that by just moving the number around. And now you could just sort of play around and look at the value at different moments in time. Or you can look over there to the right and see how fast the overall value is changing. And you can see, okay, when that changes, it changes pretty quickly. Right? When this one changes, on the other hand, wow, you can see that it changes the value of the overall expression really fast, right? You can also see as this number gets more negative, right? And notice I'm now moving it down because it's going to be more negative. I guess that affects the value, but only a tiny, tiny bit, and you can see that by looking over here. But then if you play around with the exponent, you can see that just adjusting it a little bit makes a really big difference, right? And the intuition is that students or people trying to learn the situation can play around these different values and directly sort of see how they're having an impact in the algebraic structure. And then, of course, when you get to your answer, you can say, okay, well, I want to put the big things where the big impact is, so I can drag that 9 down on top of that e. That's where the really big impact is. And I can see, of course, when I set this out to 9, first of all, I've gone way off the edge. And that's okay. If I want to, if I really want to see that, I can always come over here, set it into Move Graphics View, and just slide this back down. And that's just your standard GeoGebra action. Right? And now I can see, wow, I'm really making this thing big. Look, there it goes off again. Right? That's okay. I can just keep sliding it in. You can see, wow, I'm really doing something very big to that, right? Oh, and there it goes again. And again, what you can do is sort of play around, see how you're making this thing just huge, and get a real feel for that. And then when you've got your answer, you can just pick these up and drag them in. So that's one vision of how you might play with this kind of situation. All right.